Good day in our science and safety report today. We take a closer look at the class of chemicals that may already been inside your home. Pyrethroids. These synthetic compounds modeled after natural pyrethrin found in chrysanthemum flowers have become a global staple in pest control. But behind their widespread use lies the powerful biological mechanism and grows concern over their broader impact.
If you're looking for natural pesticides that will knock down many bothersome pests like cockroaches, flies, and wasps, then look for products made with pyrethrins or pyrethrum. Pyrethrins are natural, organic compounds used as fast-acting and effective insecticides. In this video, we'll teach you about these active ingredients and show you how to use popular products made with them. To shop for the products featured in this video and to learn more about pest control, click the icon in the top right of the screen or click the link in the description below. Pyrethrins, registered for use as insecticides since the 1950s, are natural compounds that have been processed to use as insecticides. They come specifically from chrysanthemums, and they consist of 6 different chemicals: pyrethrin 1, pyrethrin 2, cynarin 1, cynarin 2, jasmolin 1, and jasmolin 2. If you click this video looking for pyrethrum, don't worry. The terms pyrethrum and pyrethrins are often interchangeable and refer to the same thing. Some establishments, however, will refer to the physical crushed flowers as pyrethrum and the actual chemical components as the pyrethrins.
Pyrethroids are widely used for their rapid knockdown effect, eliminating insects quickly even at low concentrations. For humans and other mammals, the risk is generally considered low, but for insects, exposure is often fatal. Now at the center of their action are voltage-gated sodium channels. This is a critical component of the nervous system. Under normal conditions, these channels regulate the flow of sodium ions, allowing nerves to transmit signals in a controlled manner. Now pyrethroids disrupt this balance. They force these channels to remain open, causing a surge of sodium ions into the nerve cells. The result is continuous, uncontrolled nerve firing, leading to hyperactivity, loss of coordination, paralysis, and ultimately death.
Pyrethrins work on contact with targeted pests. These ingredients interfere with the pest's central nervous system, causing muscle spasms and inflicting paralysis. This creates an inability to function or eat, eventually leading to the pest's death. Pyrethrins are some of the safest pesticide chemicals available to consumers. When applied according to label directions, pyrethrins are safe to use in and around the home. Pyrethrin compounds break down quickly in the environment, so pets and children are safe after the applied product dries. That being said, always wear the proper personal protective equipment or PPE when applying pyrethrin insecticides and keep them out of reach of any children or pets.
Toxicologists classify pyrethroids into 2 major groups, each producing distinct urological effect. The first type of pyrethroids are the compounds that lack a cyano group and are associated with what experts call a T syndrome or tremor syndrome. Affected insects exhibit fine tremor, restlessness, and heightened sensitivity. Common examples are the alethrin and permethrin. The second type of pyrethroids, in contrast, they contain a cyano or CN group, which make them more potent. They are linked to CS syndrome, characterized by severe symptoms such as convulsion, excessive salivation, and prolonged paralysis. Dalpamethrin is one of the most widely used examples of this category.
While pyrethroids are less toxic to humans due to faster metabolic detoxification and lower nerve sensitivity, experts warn that high levels of exposure are not without consequence. Reported effects include skin irritation, known as paresthesia, along with respiratory discomfort, particularly in poorly ventilated environments. Environmental impact is also under scrutiny. Although pyrethroids degrade quickly when exposed to sunlight, they pose a significant risk to aquatic ecosystem. Even small concentration can be highly toxic to fish and other aquatic organisms. Additionally, these chemicals tend to bind tightly to soil, limiting movement but increasing persistence in specific areas.
As the use of parasites continue to expand in agriculture and public health, scientists emphasize need for balance. Improper use does not only raise a health concern, also contribute to insect resistance derived from both behavior, adaptations, and genetic mutations. The message is clear, wherein parasites remain powerful tools in pest control. Their application must be guided for caution, regulation, and responsible use.
For more updates on science and public safety, stay with us. I'm Charles Dexter Tanathan, reporting.